Hey class, good afternoon or morning, whenever you're watching this. But we are going to pick up in chapter 3 and starting to work our way into section 2. And so last video and last class, we talked about the laws that were discovered around the 1700, like the law of conservation of mass, the law of definite proportions, and the law of multiple proportions. And these three laws really set up Dalton and the other scientists to kind of say, what is it we believe and the theories we have for the atoms. And so John Dalton came up with 5 principles or 5 concepts of what he believed to be true about the atomic theory. So let's look at those 5, and I want you guys to think with me, which ones do we still accept today in our modern atomic theory, and which of his 5 concepts do we reject? So in 1808, John Dalton was an English dude, probably had bad teeth and a funny accent, and he came up with these 5 things. So first he said, all matter is composed of small particles called atoms. Now you'll realize here he is reaching back in history, and he is talking and referring to Democritus and the idea of the atomos, which means indivisible. So he is going against the idea of Aristotle, and he is going with the idea of Democritus. So what do you think? Do we consider this to still be true today? If I have a piece of aluminum, is it true that this matter is composed of small particles that we call atoms? And yes, we would say yes, we still accept that comment today. The next idea is that all atoms of a given element are identical, but they differ from any other element. So what he's saying here is that all matter have atoms. And this atom inside this aluminum, they're all the same. So if there's billions upon billions of atoms in this thing of aluminum, all those are identical. And we would say, yes, this is still true today, that all the atoms inside aluminum are all identical. They all have 13 protons. Now, we could be picky and we could say now that we know about isotopes and that some of the isotopes might be slightly different, but overall, what you need to know is that, yes, most atoms in here are 100% the same with 13 protons, and they're consistent. And if I have another element like copper here, copper is going to be made of atoms too, but these atoms are fundamentally different than these atoms in aluminum. These atoms are going to have 29 protons, where these atoms are going to have 13 protons. Now again, John Dalton didn't know about protons yet. He didn't know about neutrons, and he didn't know about electrons, but he had this idea of an atom. And this is where his thought process was leading him. So number 3, atoms cannot be subdivided, created, or destroyed. Do we agree with this today, or do we disagree with this today? Well, we would say that we disagree with this today, because we're going to learn here in the next few slides that the atom is not the most indivisible thing there is. The idea that Democritus had when he first quoted the phrase atom was wrong. We know we can break up the atom, and we know the atom is made up of protons, neutrons, and electrons. And we know that when we create an atom, that's called nuclear fusion, and we know when we destroy an atom, that's called nuclear fission. Number 4, atoms of different elements can combine in whole number ratios to form compounds. And here we say, yes, this is true. Yes, sodium and chlorine do exist in a 1-to-1 whole ratio. Yes, hydrogen or water, H2O to oxygen, 2 hydrogen do agree with 1 oxygen. And so we would say, yeah, we do agree that atoms from different elements can combine to form other compounds in whole number ratios. And the last one, in a chemical reaction, atoms can be combined, separated, or rearranged. Is that true? Well, yes, I can take a sodium, I can take a chlorine, and I can put them together and I can form salt. I can take some hydrogen, I can take some oxygen, and I can combine them to form sodium chloride. So yes, we still agree with this theory today. So here's a video, and it's about J.J. Thomson's cathode ray tube. So go ahead and pause my video and look in the description for the link to watch this guy do a great job explaining what's going on inside that cathode ray tube. Go ahead, I'll wait. So what we can see here after watching that video is that atoms are divisible, that there is something smaller called an electron that actually makes up the atom. And so what we thought to be true about an indivisible atom is not correct. It can be broken up. And now today we accept the idea that nucleuses are the center of the atom, that we have protons with a positive charge, we have neutrons with no charge, and we have an electron cloud on the outside where electrons exist. Now, how do we get here? Well, I want to talk to you about another experiment that helped us understand the model we accept today. But before we get that, let's make sure we understand what subatomic particles mean. Subatomic particles are just the particles inside the atom, just like a submarine goes inside the water. So here we have protons with a positive charge, neutrons with a neutral charge, and E with a negative for electrons with a neutral charge. So how do we figure this out? Well, we first realized, just like you saw in the video, through J.J. Thomson's cathode ray tube, the discovery of electrons. Again, the video talked about this, and these next two slides just reiterate what you saw in that video with the cathode ray tube. We have a negative charge flowing through a vacuum. In the video, he said it was a vacuum of nothingness. That means just like outer space, inside that tube was nothing except an electric current. Back in JJ's day, he used noble gas, which is probably neon is what he used, and it's inert, means it doesn't react to anything and would give you the same effect, but the YouTube video you watched was probably a little clearer. So when we passed this through, we noticed that when we introduced the presence of a magnet, that line, that ray, that beam went away from the negative and towards the positive. Well, what's that mean? Well, if this beam went away from the negative and towards that positive, that means this beam has a negative charge. But we still don't know what it is yet. So J.J. Thomson also went and took the mass of it, and he compared the mass of this thing that's electric to the mass of to a hydrogen atom. So think about what a hydrogen atom is. A hydrogen atom is just one proton and one electron. And when he compared this thing that was in this tube to the mass of that proton and that electron, he found out that this thing, whatever it was with a negative charge, was 2,000 times lighter or smaller or with less mass than that hydrogen atom. So he just found something that existed that was smaller than the smallest atom. And that's where we came up with the idea of electron. And so we now see that there is this idea that inside our atom, we have something with a negative charge. And because of that, you'll see here in a second, we have to have something with a positive charge. So here's what Thomson realized, that no matter what element you had, whether you had copper or aluminum, they were both existed and they both had the same properties. They both were solid still, they both were tangible, and they both did not shock you when you touched them. That they both seemed to appear to have a neutral charge, and they both appeared to be uniform throughout. And so he realized that all electrons all atoms had to have electrons. And he came up with this idea of the plum pudding. He believed that there's a bunch of positive goo or positive stuff with this idea that electrons would be inside of it. But you could pull out those electrons because we know that metal can conduct electricity, or I can get static electricity on my hand and shock somebody. Therefore, we can move around electrons. So in 1911, here comes Ernest Rutherford. He wants to test out and he wants to try test out the theory of what Thomson came up with. So what does he know? Well, he knows atoms have a negative charge or electric charge. He knows atoms are typically neutral because when I go around touching different matter, I don't get shocked. So there has to be some positive charge there to balance them out. He also looked at the difference between a hydrogen atom and a helium atom. What he did was he took the hydrogen and he got rid of the electron, and would notice it has a mass of 1, if you look on your periodic table, 1 AMU, and it also has a charge of 1. But when he looked at the helium, he realized it would have a charge of 2 when it took away the 2 electrons, but it would have a mass of 4. So what the heck's going on? When I doubled the charge and I went from 1 to 2, my mass went from 1 to 4. So he had to realize there was some other particle in there that accounted for the mass but had no charge, and therefore he came up with the idea of a neutron. And so when he took this idea of a neutron and he wanted to see what was going on inside the atom, what did it look like? Did it look like the plum pudding that Mr. Thomson looked like, or did it look like something else?